Welcome, welcome one and all. So in this lecture, we will discuss the concept of random variable. So here, the definition of random variable is there. So a random variable is a function. A random variable is a function that associates a real number with each element in the sample space. Okay. So this is the definition of random variable. So to understand this definition, there is an example. So we have three coins which are being tossed, okay, simultaneously. Three coins are being tossed simultaneously. First, we have to construct the sample space. So our sample space will be head, 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 then two head, one tail. So here we have three heads, okay? So then two head, one tail. Now this combination, this is a combination. Please mind, this is a combination, okay? So this combination, it has two heads and one tail, and it will have permutations. Permutations means just rearranging the positions of heads and tails. So how many permutations this combination will have? Actually, it will have 3 factorial divided by 2 factorial into 1 factorial. I repeat, this combination, it will have these many permutations. Why? Actually, why this 3 factorial? Why this 3 factorial? Because there are total 3 positions. You can see there are total 3 positions. And why divide by 2 factorial? Because out of these three, head and tail, two are same. Two entries are same, means there are two heads. Okay. And why this 1 factorial? Because there is only one tail. So if you simplify this, so it will come out to be 3, means this combination, the combination of head, head, tail, this combination of head, head, tail, it will have 3 permutations. So what are those 3 permutations? Head, tail, head, and tail, head, head. Okay. Now, two tail and one head. Okay. So now even this combination, please mind, this is also a combination of two tails and one head. This is also a combination of two tails and one head. Even this combination, it will have same number of permutations. Why? Once again, there are three things, okay, three places to be arranged in arranged in three places. And why divide by 2 factorial? Because out of these three, two are same. What two are same? Two tails are same. Okay. And then obviously this is also 3. So tail, head, tail, and head, tail, tail. So these are those 3 permutations. Okay. And the last one will be 3 tails. Okay. So these are our total outcomes. Okay, the total outcomes when 3 coins are tossed simultaneously. The 3 coins are tossed simultaneously. Okay, so this we will call it our sample space. Okay, now the concept that I have explained here in order to calculate these permutations, it can be applied here also. How? There are 3 positions, so that's why 3 factorial. Divide by 3 factorial. Why 3 factorial? Because all the 3 are same. All the 3 entries, okay, they are same. They are all heads, okay. So that's why how many total permutations? 1, okay. Means to say, if you permute these heads, okay, once again, you will not get a new permutation. You will again have a same permutation, okay. So now, we have actually total 2 raised to power 3 elements in this sample space. You can see 2 raised to power 3, which is equal to 8 elements in our sample space. You can count. Here it is 1, then second, third, fourth, fifth, sixth, seventh, and eighth. Okay. And if by chance, if we toss four coins simultaneously, then how many elements in sample space will be there? There are 2 raised to power 4, 16, and it will go on. So if we are tossing n coins simultaneously, if we are tossing n number of coins simultaneously, so how many points will be there in this sample space? 2 raised to power n. Okay. So now one remark here, tossing three coins simultaneously and tossing one coin three times, they are same. Now, this is our sample space. On this sample space, we are defining a random variable x. And this x, it denotes number of heads. So what is our x here? So x here, it is number of heads. Okay. Now, this x, it is assigning a number to this element of a sample space. Means, what is the value of this x at this outcome? Actually, this is 3. Why? Because for this outcome, 3 heads are there. And x, the value of x at head, head, tail. What is the value of x at head, head, tail? It is 2. Okay. Why? Because in this outcome, there are 2 heads. Okay. So that's why this x, it is behaving like a function. Actually, this x, its domain is sample space and its range is set of real numbers. This x, it is a function whose domain is sample space and whose range is or codomain is set of real numbers. Okay. It is just behaving like any another ordinary function from some set a to b. Okay. That's how we define f at x, and now this fx, its value will be here. For example, if I take say x square minus 3x plus 2. Okay. So just like this function, x is also a function, okay, which is associating a real number to each element of the sample space. Now, similarly, the value of x at this element, it is again 2, and the value of x at this element, okay, tail, head, tail. So I write here. So the value at, wait, please. Yes. So x at tail, head, tail. I am taking any element. So here its value is 1 because there are only one head in this outcome. And x at t, it is nothing but 0. Okay. So this is our random variable x. Now, next was find the values which this random variable can assume. So how many values it can have? So x can be 0. Okay. X, this can be 0, 1, 2, and maximum 3. Okay. Now, we have to find the probability distribution of this number of heads. We have to find the probability distribution of these number of heads, means the probability distribution of this x. Okay. So for that, actually, we will construct a table. So here x, I will write the values. Okay. And here it will have a value 0, then 1, then 2, and then 3. So probability x takes the value x. So here probability x takes the value 0. Okay. Then probability x takes the value 1, and then probability x takes the value 2, probability x takes the value 3. Now, If I denote this thing by f at x, means this thing, suppose I denote it by f at x. So obviously, this value is nothing but f at 0. And this value, it is f at 1, the value of f at 1. This value, it is f at 2. And this, it is f at 3. Now, what are these values? So, first of all, x0, probability that x is 0, means probability that there is 0 head. So, this probability is nothing but 1 by 8. How it is 1 by 8? Out of the total 8 number of outcomes, okay, total 8 number of outcomes, there was only one favorable case where there was 0 head, where there was 0 head. What was that favorable outcome? Actually, this outcome I am talking about. Okay. And for this one, there is one head. The answer is 3 by 8. Okay, this you can see that out of the total 8 outcomes, there are 3 favorable outcomes where we have only one head. Basically, so it was tail, head, tail, and its 3 permutations. Tail, head, tail, and its 3 permutations. And similarly, what is the value here? Even it is 3 by 8, and even this is 1 by 8, means probability that there are two heads. Okay, so actually head, tail. This was one combination and it has 3 permutations. This combination, this has 3 permutations. So that's why 3 by 8, and even it is 1 by 8, because 3 heads. Okay, what is the probability? Here it is the probability. See here, probability that there are 3 heads. Okay, so that was only one favorable case, that was head, head, and head. Okay. Now, if you look carefully, this table, okay, actually this table, it is giving us distribution of the probability, means how probability is distributed. Okay, so that's why this is what we call probability distribution. Okay, the probability distribution table, we can call it probability distribution table. Okay, but in the technical language of statistics, we don't use this word table. We simply say that this table is nothing but our probability distribution. Okay, it is just like the fact that in our lower classes we used to have frequency distribution tables. If you recall back that, yeah. So we used to have, say, some data, say some marks, okay, and then we were having this side frequency, say here, say between 0 to 10, 10 to 20, here 20 to 30. Okay, example, this is just an example. So here, say it is 5, say 4, say 2. Okay, so such type of tables, we call them frequency distribution tables. Why? Because these tables, they give us distribution of the frequency, means how frequency is distributed, how frequency is distributed over various values of the data, how frequency is distributed over various values of the data. Yeah, data may be anything. Here it is marks, it may be weight, time. Okay, data may be of any type. So just like these tables, even this is also a table. So here, so this one is also a table, but this table, it is giving us distribution of the probability. How probability is distributed over various values of the random variable, how probability is distributed. Okay, so that's why this is what we call the probability distribution. And this function fx, okay, this which we have defined like this function, it is what we call probability distribution function, fn dot. Fn dot means function. Okay. Why? Because this function, it gives us distribution of the probability. This function gives us distribution of the probability over various values of x, the random variable. Okay. Now we have another example. Now four coins are tossed. We have to construct the sample space. So what will be our sample space? Actually, head, head, head. First one, head, head, tail. So three heads, one tail. Now this combination of three heads and one tail, it will have 4 factorial divided by 3 factorial into 1 factorial. These many permutations. Okay. Okay. So why 4 factorial? Because there are four things to be arranged in four places. Okay. Why divide by 3 factorial? Because out of these four, three are same. Three are heads. And this 1 factorial, it is corresponding to this t. Okay. So we have this combination which will have these many permutations. Now, what are these four permutations? They are actually head, head, tail, head, then head, tail, head, head, and then tail, head, head, and head. So you can very well see this T, I am shifting. So first it is here. You can very well see it is here. Now, once it is here, okay, and then it is here. Means this T, one by one, it is being shifted. Okay, now head, tail, tail. This combination, this will have 4 factorial, then 2 factorial and 2 factorial. Basically, six, permutations will have. It will have this combination of two heads and two tails. This will have total 6 permutations. Actually, why this 4 factorial? Because total 4 things are there. 4 letters are there, which are to be arranged in a straight line or in a straight line, 4 positions in a straight line. Why divide by 2 factorial? Because 2 are same. Again here, why 2 factorial? Because further 2 entries are same. Now, how to get these 6 permutations? For that, what I do, I keep the first position head. I keep it fixed and I permute the remaining three. So tail, head, tail, and tail, tail, head. You can very well see that the first position is fixed, okay, and the remaining three, they are being permuted. Now, two tail and two head, even this is one of the permutation. Again, this T I will keep fixed. This T I will keep fixed and I will permute these three. So you can see head, tail, head and head, head, tail. You can very well see that I am permuting these. So tail, head, head, here head, tail, head, 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 tail. So total how many permutations are there? They are 6. And similarly, we will have 3 tail and 1 head. Even this will have tail, tail, head, tail, head, tail, and head, tail, and tail. Means it will have 4 permutations and there will be last point of the sample space that will be nothing but all tails. That will be all tails. Okay. Even this one, all tails, all 4 tails, and this one, all 4 heads. They can have how many permutations? So 4 factorial divided by 4 factorial, which is 1. So obviously these combinations, these two, okay, all 4 tail and all 4 head, they will have only 1 permutation. naturally, if you permute these tails or you permute these heads, you will not get a new permutation. Okay, so there is only one permutation. So now on this sample space, we are defining a random variable x, which denotes the number of tails now. Okay, so this x, what values it can have? This x, it can have either value 0 or 1 or 2 or 3 and maximum 4. Okay, why? The value of x at tail, tail and head, head. So what is the value of this x at this outcome or this element of the sample space? It is nothing but 2 because there are two tails. X is number of tails in any element of the sample space. So x at tail, head, head, head. It is 1. The value of x at tail, 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 head, it is nothing but 3. Okay. So the value of x at this combination, we can say outcome, it is 4. And the value of x at this outcome, it is nothing but 0. Now we need this probability x is x. So here probability x takes the value 0, probability x takes the value 1, probability x takes the value 2, and similarly here probability x takes the value 3 and 4. And if I define this by our fx, so here it is f at 0, this is f at 1, this is f at 2, and same here. Now, what are these probabilities? So, first of all, what is the first probability? Actually, the probability that there is zero tail. Probability that there is zero tail. Tail, it is 1 by 16. Total, out of total 16 sample points, there is only one favorable sample point for zero tail. And what is that favorable? That is nothing but all four head. Okay. So here we are using the very classical definition of probability. So the probability of any event A, it is nothing but number of favorable outcomes for E, number of favorable outcomes for the event E divided by total, the total or exhaustive number of outcomes. Okay. So this definition, this very classical definition of probability we are using. Now here, what is the value of f? Means this probability x is 1. So this is nothing but 4 by 16. And similarly here it is 6 by 16. Okay. And here it will be again 4 by 16. And here it is 1 by 16. Actually, there are six favorable cases for two tails. There are six favorable cases for two tails out of total 16 cases. Okay, or 16 outcomes. Okay. So rest you can very well figure out. Now, here one important observation that this affects, okay, this affects, it is never negative. This affects is never negative for all values of x or for any value of x. This fx is never negative for any value of x. Why it is never negative? Just so why it is never, why this fx is never negative? Because this fx, it is basically a probability. This fx is basically a probability. So probability can never be negative. And there is another property of this fx. It is nothing but the summation of fx over entire range of the random variable. Means f at 0 plus f at 1 plus going on f at 4. If you add all these probabilities, obviously, what will you get? You will get nothing but 1. One can very well see that 1 by 16 plus 4 by 16 plus 6 by 16 plus this and plus this, it will be nothing but 1. Now, the same two properties, they were there in the previous example also. Even here, if you see that fx, this fx was never negative, non-negative for all values of x. Summation of fx over entire range from x0 to 3. Here x is from 0 to 3. Okay, in the second example, it was x from 0 to 4. Okay, even this is also 1. So 1 by 8, you can see 1 by 8 plus 3 by 8 plus this, it is 1. Now, these two properties, they are important. We will come back to these. But before that, let's see some more examples. So here, two balls are drawn in succession. In succession means one after the other and without replacement. Now, drawing the balls or two balls in succession without replacement and drawing the two balls simultaneously. Drawing the two balls simultaneously. Okay, this case is both the cases are same. If I am drawing two balls in succession, means one after the other without replacement. So ultimately, I am drawing two balls. Okay, means two balls simultaneously. Okay, and then we have uh, we have some number of black balls. So for from an uncontaining four red, actually it should have been four red balls. Okay, the four red balls and three black balls. Find the probability distribution of the number of red balls selected. Now, if you have observed in the previous two questions, even in those, we were finding probability distribution of some certain number of things. We were finding the probability distribution of some certain number of things. In the first question, it was the probability distribution of the number of heads. Okay, actually, in both the questions, no, in the first question, it was the probability distribution of number of heads, and in the second question, it was the probability distribution of the number of tails. Okay, but whatever the case was there, this number of heads or number of tails, it was our random variable, if you recall back. Okay. So even in this question, we have to find the probability distribution of some certain number of things. We have to find the probability distribution of some certain number of actually balls. Now this certain number of balls, it will be our random variable. I repeat, whenever we have to find the probability distribution of, or for, okay, the probability distribution of some certain number of things, that certain number of things will become our random variable. Okay, so here what is y? Y is the number of red balls selected. Okay, so that's why what values this y can have? This y, it can have values either 0 or 1 or 2. Okay, so this y, when it will have value 0, if both the balls are black. When this will have value 1, if one of the balls is black and one is red, because what is y here? Number of red balls. And this value, it is here in this outcome. So the value of y at RR, the value of y at this element of the sample space, it is 2. The value of y at RB and at BR, it is 1. And the value of y at BB, this outcome, it is 0. So this random variable y, it is associating a real number. It is associating a real number with each element of the sample space. Now, probability y takes the value y. So here, probability y takes the value 0, probability y takes the value 1, probability y takes the value 2. Yes, I may denote this by, say, some function gy. So here it is g at 0, here it is g at 1, here it is g at 2. The value of the function at g at 0, the value of the function at g at 1, and here at 2. Now, this value, the very first value, it is nothing 4C0 into 3C2 divided by 7C2. Actually, 4C0, because we are selecting 0 red ball. This 0 red ball. Out of total, how many red balls? 4. Okay. So how many ways are there to select 0 red ball out of 4? It is 4C0. And if there is 0 red ball, there will be the two balls, the two selected balls. They will be black. Now, 2 black balls out of total, how many black balls? 3. And they can be selected in how many ways? 3C2 ways. Okay. So basically, what is this case? Suppose we have B1, B2, and B3, the 3 black balls. Now, the 2 black balls that we are selecting here, the 2 black balls we are selecting, they can be B1, B2, they can be B2, B3, or they can be B1, B3. So total, how many ways are there? 3 ways. And this 3 is nothing but 3C2. Okay, this is nothing but actually 3 factorial divided by 2 factorial into 1 factorial. Actually, what is n choose r, NCR? It is n factorial, r factorial, n minus r factorial. Okay, just wait. Yeah. So, NCR, the number of ways of selecting or choosing are things out of n. Okay. So that's why this is 3. Similarly, suppose if we have to choose 2 red balls out of 4 red balls, R1, R2, R3, R4. I have to select 2 red balls. Where I have to select 2 red balls? Actually here. So in how many ways I can do so? Actually, that is nothing but 4 choose 2, 4C2. Okay. So what is 4C2? That is nothing but actually 6. You can very well see. Now, what are these 6 ways? Actually, the 2 red balls, they can be R1, R2. They can be R1, R3. Okay, so I write, so R1, R2, R1, R3, R1, R4, R2, R3, and R2, R4, and the last is R3, R4. So total 6 combinations means we can choose 2 balls out of 4 in how many ways? 6 ways. Okay. Please mind one thing, that number of ways of selecting nothing means selecting nothing, means if I have to select zero black ball, if I have to select zero black ball among these three, so in how many ways I can do so? That is 3C0. Selecting zero black ball out of three. In how many ways I can do so? That is 3C0. So, and what is 3C0? That is equal to 1. Means there is only one way to select to select no black ball out of three. Okay, there is only one way to select zero black ball out of three black ball. And what is that way? That way is select nothing. Select no black ball. Okay, so it is just an abstract statement that even no selection is also a selection. Okay, selecting nothing out of a given number of things, it is also a one way of selecting. So actually NC0, this is equal to NCN, which are always one, and NC1, it is equal to NCN minus 1, which are always equal to N. Okay, actually NCR, this is equal to NCN. Yeah, so I write here. So this is NCN minus R. So NCR, this is equal to NCN minus R. Okay. Basically, what is this NCN minus R? It will be N factorial divided by N minus R factorial and N minus N minus R factorial. Okay. If we apply the same definition, the only thing, instead of R, but we have N minus R. So what is this thing now? It is N factorial. And if you look here, N cancels out and this minus will become plus. So R factorial. And this thing, it is N minus R factorial. And this is nothing but NCR. Okay. So that's why NC0, this is equal to NCN1. Means how many ways of selecting zero thing or n things out of total n? That is 1. Okay. So if I have to select all the things out of given n things, in how many ways I can do so? Only one way. What is that way? Select all. In how many ways I can select zero thing out of n? How many ways I can select? One way. What is that way? Select nothing. Okay. In how many ways I can select one thing out of n? That is total n. In how many ways I can select n minus 1 things out of n? That is again n. Okay. And now similarly, the rest of the probabilities that we will calculate. So up to here, we were having only one, but we need some more also. So here, this probability y is 0. So what is this probability? Actually, this we denoted by g at 0. It was 4C0 into 3C2 divided by 7C2. Probability y is 1 means probability that there is one red ball. Probability that there is one red ball among the two balls selected. So that is nothing but 4C1 into 3C1 divided by 7C2. So means this one red ball. Okay. So this one red ball, it will be coming out of 4 red. Okay, so 4C1 and 3C1. Because if one ball is red among the two balls selected, one will be black. Okay, so one black out of total how many? 3. And why divide by 7C2? Because ultimately we are selecting total 2 balls out of total 7 balls. So selecting 2 balls out of 7, it can be done in 7C2 ways. Probability y is 2, okay, which is nothing but the value of g at 2. So this value, what will be this value? So I am writing here. Actually, this will be 4C2 into 3C0 divided by 7C2. Okay, so this is nothing but probability y is 2 and this is g at 2. Okay, so this is this is the probability of two selecting two red balls, means both the balls which are selected both are red. Okay, it is nothing but this. Now, if you calculate these one, so it is 6 into, because 6 into 1 divided by 21. This is 4, sorry, it is 1 into 3 divided by 21. And this is 4 into 3 divided by 21. Okay. Actually, yes. So 7C2, what is its value? The value of 7C2, it is 21. Now, if you add all these, means this plus this, the answer will be 1. Okay. And obviously, even here, our G at Gy, even it is never negative for any value of y. Gy is never negative for any value of y. And moreover, the sum of all the values. So the sum of all the values of this gy, or we may write that this probability y is y over entire range 0 to 2 of the random variable. What is this sum? It is nothing but 1. Actually, uh, in the heavy industries like the coal industry or steel mill industry, the workers, they have to wear safety helmets. They have to wear safety helmets. So once the workers, they are on to the duty, they have to get these helmets issued, and once they are off the duty, they have to submit these helmets, safety helmets. Now submitting back means here checked them. Here it is written who had previously checked them. Actually, a stock room clerk returns 3 safety helmet at random to 3 still meal employees who had previously checked them. Who had previously checked them means who on the previous day they have submitted back. They have submitted back. Also, obviously on the next morning, okay, they will get these helmets issued from the this stock room clerk. Okay, so actually this check them means this term it is coming. It is just like in hotels we check in, check out. Okay, so here this previously checked them means these uh, 3 helmets they were checked them means they were submitted back. Checked them means submitting back, submitted back. Okay, submitted back on the previous day. Now, if Smith, Jones, and Brown in this order, means first it was Smith, then Jones and Brown, receive one of these 3 hats, means on the once their shift is on, so they receive these hats in this order, means first it was Smith, then it was Jones, and then Jones, and then Brown. List the sample points for the possible orders of returning back. Returning back means again checking them. Okay, returning back. And then find the value m of the random variable m that represents the number of correct matches. Now, one can see there is a certain table here. And here we have the values of the random variable m, means this value, this m, what values it can take. Okay, so this m either it can be 0, 1, and 3. The value 2 is not possible. Why? Uh, why m is 3 here? Why m is 3? Because what is m here? M is the number of correct matches. M is number of correct matches. So, if you see here, Smith returned back first, then Jones, and then Brown. Smith, Jones, and Brown. Okay, one thing here. What is the meaning of correct matches? Correct matches means uh, if they return the helmet in the same order in which they have received in the morning. In the morning, they have received in this order. So if in the evening, they are again returning back in the same order, means Smith returned back first, then Jones, and then Brown. Then how many correct matches are there? There are three correct matches. Now, why for this one, why for this order, it is one? Because here only Smith has returned in the same order as that in morning, because in the morning it was SJB, means Smith, Jones, and Brown. But now means this is in the morning, this order is in the morning, but in the evening Smith is returning in the same order, but Brown and Jones, they are not returning in the same order. So how many correct matches are there? There is only one correct match. And similarly, even here, there is only one correct match. What is that correct match? It is only J, the James. Okay. And even for this one, what is the correct match? It is one. What is that correct match? It is only B, Brown. Remaining J and S means the James and Smith, they are not returning in the same order. In the order they have received in the morning. And what about these two? These two outcomes. There is no correct match. Okay, so that's why these are the values which this random variable can have. And moreover, what is the value of m? This m at this outcome. What is the value of m at this outcome? It is 3. Means here there are all the 3 correct matches. And m, what is the value of m at SBJ? It is nothing but 1. Okay, so here the random variable, it is associating a real number with each element of the sample space. Now here, one thing, how to get this sample space. Once again, look, there are 3 helmets, and first helmet, it can be returned in how many ways? 3 ways. What 3 ways? Means first one, it can be returned either by Smith or Brown or Jones. So this can be returned in how many ways? 3 ways. Means first, either it can be Smith to return first, or it can be Brown to return first, or even issue first, or Jones can be first one to return or issue the first helmet. Now, the second helmet, it can be returned or issued in how many ways? 2 ways. Why? Because one is already there. Okay. So it can be returned in how many ways? 2 ways. And third one, it can be returned only in 1 way. So total, how many ways of getting these returned or issued? It is 3 into 2 into 1, that is 6. And what are those 6 ways? They are here. Okay. So for these 6, how to write down? Just write any order. Say I am writing as JB. Okay. Now keep this S fixed. Keep this first entry fixed and permute these. So it is B and J. Now write, you can write BSJ and keep this B fixed and permute these. So J and S. Now start with obviously J, JSB, fix this J and permute this S and B. Means one, you start with S, then permute J and B. You start with B, you permute S and J, you start with J and permute S and B. So you can see the same six sample space elements or points are there. Now, we have to find the probability distribution of the number of correct matches. One can very well see, find the probability distribution of number of correct matches. Once again, we have probability distribution of some certain number of things. We have the probability distribution of some certain number of things. So this certain number of things, it will be our random variable. Okay, so here this random variable, we are denoting it by m. Okay, one thing here, that to denote the random variables, actually we use the capital letters. It may be capital X, capital Y, capital Z, Z. Here it is capital M. Okay, now this m, what values it is having? Either it is having value 0, 1, value 2, it is not attaining this value 2, but still we are writing and we can write. So here it is 3. And now uh, probability m takes the value m. So here probability m takes the value 0. Here probability m takes the value 1. Probability m takes the value 2. And probability m takes or assumes the value 3. Now, what is this value? 0. 0 correct match. What is the probability of 0 correct match? Actually, it is nothing but 2 by 6. 2 by 6. Because out of total 6 outcomes. So once again, so just wait, please. Yeah. So out of total 6 outcomes, there are only 2 favorable outcomes for 0 correct match. And similarly, what is this probability? It is 3 by 6 because out of total 6 outcomes, there are only 3 favorables for 1 correct match. Match means same order. And even actually here it is 0, 0 by 6, which is 0. And obviously what will be this? It is 1 by 6. And if I give this, say, if I denote it by f at m, which is nothing but probability m is m, then obviously that fm, it is non-negative for all values of m, and the sum of all these fm over entire range of m, that is nothing but 1. Okay, so here this is what's the meaning of the random variable, which is a function which associates a real number with every or each element of the sample space. And moreover, we have seen that what is probability distribution and probability distribution function. Okay, so basically we are having a distribution of the probability over various values of the random variable and a function which gives us the distribution of the probability. That is what we call probability distribution function. And whenever we are being asked in our exam, whenever there is a question like this, that find the probability distribution of some certain number of things, whenever we have this type of question in exam, find probability distribution of some certain number of things, that certain number of things should become our random variable. Then we must see that what values that random variable can have, and corresponding to those values of random variables, we have to find the corresponding probabilities, and that will be our solution of the question. Okay, so thank you.